Picture this. You're a 21-year-old computer nerd, staring at the abyss of your monitor. The universe whispers, "Go outside, do something," but no, you decide to create something eternal. And when I say eternal, I'm not referring to, I don't know, curing cancer or building the next grinder. No, I'm referring to a digital Frankenstein, the kind that turns your grandma's fridge into a clunker with the sole purpose of distributed denial of service. That and keeping your grandmother's rakia cold, of course. Welcome to the story of Paras Ja, or better known as Anna Senpai and his Mirai Botnet. Let us rewind to 2016. CIA spyware known as Pokemon Go was peaking, Harambe was fresh in the grave, sadly, and Anna Senpai, along with his merry band of basement programmers, Dalton Norman and Josiah White, have decided to unleash Mirai Botnet onto the web of unsuspecting IoT devices. And these were not your NSA, CIA hackers in dark suits, sunglasses. No, these were kids. Kids that, went to school, sniffed glue, and other things that kids that age do, except for one thing. They decided to build one of the most notorious botnets, malware so dominant that it changed the IoT industry. They coded this malware because, get this, Anna Senpai was knee-deep in Minecraft wars. Yeah, that hellscape of a video game where pubescent kids fight over virtual dirt blocks or something. They run a protection racket. Pay up and your Minecraft world is safe. However, the competitors kept DDoSing the shit out of their clients, so they flipped the script, build a bigger, badder, meaner motherfucker of a malware. Mirai's bot used C programming language. Simple, old, lean, and mean, perfect for low IQ IoT devices, such as IP cameras, routers, and sex toys. It had a scanner which sniffed the internet like a shark in a search of exposed telnet protocol. It took control over those devices by brute forcing the login credentials to remote control services running on those devices using a laughable 68 default credential combinations. Credential combinations like admin and root 1234, shit so obvious that it's like leaving your front door unlocked in Detroit. Where did we left off? So once the malware is loaded into memory, it will just remain there without ever establishing persistence on the machine, just turning the device into a mindless DDoS machine awaiting orders from the command and control server. Reboot the machine and poof! Everything is gone. However, who reboots their IoT devices? Maybe cam girls, But the chef's kiss? Command and control server made fully in Golang, the big daddy language of Google, which is the most efficient, best big dick programming language of all when it comes to garbage collected languages. It has pretty much everything you need to build not only the backend for a malware, but malware itself and the UI as well. It's kind of all in one package. And yeah, Golang is the best. That's not even up for a debate. And while we were writing in the comment how Rust is the best, during that time I already built a backend for an e-commerce which you used to purchase your cat ears at. So yeah, Golang can handle tens of millions of devices without even breaking a sweat, like Djokovic handles pretty much every other player. And these kids were not your average teens, they were not idiots like pretty much every other teen tends to be. They were engineers who orchestrated a plague that spread to about 600,000 of these at its peak. In its very first year, Mirai Botnet flexes and sends 620 gigabits per second DDoS attack against Krebs on Security, which is a cybersecurity blog. And if you're wondering how much is 620 gigabits per second, like, it's a lot. Like, not even Bonnie Blue can handle that much in one day. Krebs is a journalist with a hard boner for Elon Musk, who did the deadly sin of all. He performed actual journalism. He published a series of articles exposing the Minecraft-induced wars over pixelated worlds. Fast forward to 2017 and Krebs drops a bombshell expose report in which he doxes Anna Senpai and his accomplices, effectively putting an end to a Minecraft warlord drama. Days later, FBI raids their homes the same way Anna Senpai raided Minecraft service. Poetic justice? Maybe. Or perhaps not, because Anna Senpai has wiped his drives clean. Wiped him like a motherfucker. However, everything caught up with them eventually. They ended up in jail for 20-30 years. Nah, I'm just kidding. They did consultancy work for FBI for a few years. That's pretty much it. That's some community service hours, basically. And yeah, they even went to one of the cybersecurity companies that was publishing and fighting their malware. And they were like, hey, we need work. Are you hiring? So join me as we explore the source code of Mirai, and yeah, we're gonna pick that brainchild of Senpai apart. This is the source code of Mirai. It has been almost 9 years ago since the author of the source code, under the pressure from the law enforcement, decided just to make it publicly available so that all of the resources of the law enforcement will be focused on the other threat actors. However, it didn't quite work. Anyhow, let's see. So first, Mirai folder contains the bot, command and control center, and just some other tools. So let's start from the Golang source code, because I love Golang. Let's start from the main file. Okay, we see that there are some hard-coded password, etc. for the database, listening address. Now this is not really good, because all of those kind of things should come from environment variable, like this port as well, etc. Like all of those values should not be configurable from the source code, especially like if somebody just takes a binary for if the binary is leaked, you're just gonna have that password there engraved. Let's see then. So what the code does, it creates two TCP listeners, and for each one of the incoming connections, it will accept the connection and create a new Go routine that will handle it. Basically, if you don't know what Go routines are, they're user space kind of lightweight threads that are handled by the Go runtime, meaning that when you spawn a Go routine, you don't actually make a OS syscall. It's so that you can have maybe like even 100,000 of them if your if your machine can support them. But then you will run into issues like the Golang runtime scheduler has to jiggle them around basically. If you have a lot of them that wait for the most of the time, then you're gonna be fine. You're just gonna park them and wait until it can put them on the schedule on some on some physical thread to be processed. Otherwise, if it's a CPU intensive workload on all of those threads, you're gonna have a lot of issues. So yeah, this is not the best way to do it, because essentially the thing there is you cannot control the amount of Go routines that will be spawned, meaning that if somebody with one machine bombards you with connections, it's gonna create a denial of service. So bringing down Mirai botnet is just start opening connections and you're gonna exhaust it completely. Especially because Mirai doesn't have any accompanying software for to help scale the command and control server, because what's gonna happen is you have a limit of about 1 million connections per process on a Linux machine. That's hard coded inside of the Linux kernel, meaning that with one single computer, doesn't even have to be that powerful, you can cause denial of service on Mirai command and control server, which is great. With low amount of bandwidth you can bring down Mirai botnet. Though nobody did it as far as I know, which is strange. Like, it's so easy to bring it down. Of course, like, the outros will probably in that case perform something else, like do some optimizations, create multiple instances of the command and control server, and then have something in front of them that will basically act as a reverse proxy, handle those connections in a round robin way or something. Let's see here. Okay, binary protocol, something custom. I don't like this for the one single fact that first you're gonna have a lot of these kind of small allocations, which, like, instead you should allocate a huge buffer where you can put all of those messages in, because if you have a lot of concurrent infections, a lot of concurrent bots hitting your command and control server, you're constantly gonna be calling syscalls to allocate some memory from the operating system, and on top of that you're gonna have a higher constraint on the garbage collector trying to clean all of that up. And that's one thing. Another thing that I don't like is all of this shit is not documented, like this should be in its own struct. That struct should perform allocation of the required memory, or have some supporting infrastructure underneath that will, in maybe arena style, allocate buffers for these messages, etc. So this is vulnerable for some buffer overflow for sure. Maybe for sure it might not trigger remote code execution, but can trigger crashes. I'm certain of that. That could be one way that in a short term you can trigger denial of service on the Mirai botnet and potentially bring it down, read X amount of bytes. Like, I mean, the way that I read this code, like, this is clearly somebody that's heavily involved with C language. The way that they wrote Golang just screams, I'm a C programmer. I'm not even good C programmer at that. Yeah, let's see what else do they have. Database. Let's go to database. Hopefully they didn't make a deadly sin of having an SQL injection. Let's see what's happening here. Okay, it's opening a connection. It's using external library. meaning that they're vulnerable to supply chain attack. Like one way of bringing down the threat actors is compromising or working with the maintainers of this package and just basically trying to do something nasty from that vector. This is all theoretical. I'm not saying that you should do it nor that anybody did it. I'm just speaking as an attacker reviewing this code. Like if I had to by any means attack this botnet, like I will do these things. Let's see then. Okay, it has a login mechanism, so it's using passwords, which is not ideal. Like I have created open source tools, command and control servers for adversary simulation, like red team engagements, and using passwords for login is not ideal because at the end of the day, if the backend is compromised, somebody can start brute forcing the hash through rainbow tables. You can use salted passwords, salted hashes for that to prevent rainbow tables. But you will just increase the computation required to do the rainbow table, etc. At the end of the day, passwords are so 90s, like super fucking old. You should use asymmetric cryptography to perform those kind of operations. And then even that now with the quantum computers, like it's so fucked up. Like I don't even know what a fucking quantum computer is. Like how am I supposed to defend against a quantum computer? And even if I design an algorithm, like some new scheme for encryption or signing of data, at least to have some integrity of data, how would you know? You don't have usually a quantum computer with shit ton of qubits to try to brute force your solution that you had. Like, fucked up. Let's see. Okay, so here, okay, it's using prepared statements. You see here that it's on a separate node specifying the values. So this will be the username variable and this will be the password. Basically, prepared statements are a way to tell the database, look, these are values and this is the SQL statement. Don't mix them together, interpret values as values, because SQL injections are basically interpreting values as a statement, meaning that an attacker can put user supplied input that will hijack the statement, and that way they can compromise the host that's running the database. They can read the data, they can modify the data. I mean, it's really context dependent, but if you have an SQL injection, you're fucked. So at least they didn't do something like that badly. Apart from that, okay, something that I notice, which also screams I'm a C developer, is the naming convention. Like Golang wants to enforce on you to use camel case whenever possible, except if you have a public property, because for example here, this is the database struct over here that's defined here, and the way that you will define a public property on that struct is by capitalizing the first letter. If it's lowercase, it's private and can be accessed only within these kind of functions that are basically attached to that struct. Let's see, move forward. Okay, some low-level operations. Okay, these kind of things I don't like. I don't like logic in repository methods. So repository methods are functions that actually get the data from the database and transform it into whatever the application uses. Sometimes it's one-to-one match between how the columns are structured in a database and how the struct will be composed in the application itself. and here they're performing logic on all of those, as far as I see from like just glancing over it. Not something that I would recommend at all. Yeah, it's like, yeah, not much structure. If I saw this code, I would be like, they didn't work as a backend developer at any commercial company, at least not any good commercial company. Yeah. So for example, how I separate all of those things, I'm gonna basically show you immediately. So this is a command and control server that I have built in the past, and the C2 server, command and control server, has first, it also has the database package right here, where it just does the initialization of the database connection, and then does the migration of the database schema, meaning creating all of the tables and columns in that table, etc. And then I have the models, which in this case are just a struct basically that will basically be one-to-one mapping of what is in a database. If I need something that's not exactly mapped to the database, I will just create a new function on the struct that works as a getter that will transform the values, perform some computation, and return the data. So we have models, and then we have repository methods, which basically, you can read the data in many different ways, and you can see here I'm not performing any kind of logic. Like, you just get data and that's it. And all of the logic is actually contained inside of the controller methods. So for example, here where we have the agents, like you get the agents through the repository methods. If it's an error, always you have to check that. If there are no agents, you write status no counted as per RESTful API design, and then you write a JSON. I have this helper function. They just basically writes it as JSON. Yeah. So yeah, this needs to be rewritten. Let's see the actual bot, the bread and butter. We have much more files, and as we have seen in the homepage, it's about 80-90% of the code is C. Okay, so here it's preventing a service from rebooting the device because, as mentioned earlier, it will just be gone when you reboot the device. It didn't have any kind of persistence mechanism. Attack.c, oh yeah, these are the DDoS mechanisms. We have HTTP, yeah, all kinds of protocols basically. It was meant to DDoS all kinds of different applications because they rented out this DDoSing capacity to people for money, and they used to make shit ton of money. Like, if from what I read online, it was tens of thousands of dollars before the inflation, before 2019. So that was quite a good amount of money. And I think that DDoSing is stupid because, like, after they DDoSed Krebs on security, Krebs just got better DDoS protection. Like, you just make your target be more secure. Like, I never understood DDoS botnets. They're so boring in a way. Let's see what we have here. Killer.c, I assume this is potentially killing some processes that it doesn't like. Oh yeah, okay, so it's killing the services that it used to exploit the device. Basically, that way it's gonna make sure that nobody comes after me. Like, I'm gonna be the bitch around here, Let's see, this is probably for resolving the command and control server, maybe some DNS resolution, resolve domain to hostname. Yeah, classic stuff that you need to code in C. Like, yeah, in C, basically, the way to do stuff is if you need something, you just code more C, which I don't like. I think that C, as much as people think it's mature, I think that right now you cannot consider it mature in a way that, for example, Golang like gives you batteries included, really really well designed standard library. Like I can go just using Golang standard library and not rely on any other external package, and build all kinds of amazing stuff with it, like backends, front end as well. Like it has some stuff that can help you build HTML powered applications. Like it's really versatile. And C, of course, you can handle the OS in any way you want, but like for example, C and C++ don't have standard networking library, which in my opinion is something that, like, come on, it's 2025. Like these aren't 80s anymore. Okay, this is bread and butter of the malware. This is the scanner. This scans telnet devices and makes them their bitch. Okay, so here we have something. Basically, I assume that this out entry here is meant to obfuscate the strings, because otherwise they probably would have just written root admin instead of doing this kind of byte thing. Again, there are better ways to do it. Like, what if you want to add more or something like that, or just change any value? A better way to do it is using pre-processing, and C has some limitations in that regard. C++ is much more effective for malware development, like by orders of magnitude. And if you still prefer C language, you can still build just some subset of your malware inside of C++ to allow you to use some advanced features, and that way you can still use your all of these things you like from the C, the style, the functions, etc., the coding patterns, but utilize just like 5% of the sugar from C++. Okay, just check, see if there is anything running on 2323, which is alternative telnet port, and standard 23 port for telnet. The simplest, most effective way to protect against this kind of shit is, in your organization, just create a new list of standardized ports. Like SSH, instead of being on port 22, now it's on port 3568, for example. Like, you can do this kind of stuff. Like, the default ports are basically somebody way back, I assume in the 80s, 90s, choose those ports, and now everybody is using them. Like, even the IP protocol, private subnets were just example that one guy put in a document, and everybody that was setting up networks was basically following that guide, because it was like way back. I cannot even recall which year, because I was not even in my father's balls in that moment, and everybody followed that guide, and now every like home network is 192.168, just because somebody wrote it in a document. Okay, just perform some network configuration, communication. Yeah, makes the telnet happy. Receives the thing, checks the prompt and see if it's something that it recognizes, etc. Yeah, pretty much standard brute forcer. Nothing too, like, out of the ordinary. Yeah, basically you see that this malware is super simple. There are just two components to it. You have three actually. You have the infector. Like the infector is a separate component that will infect the devices using the credentials that the bot actually found. You have the command and control server that will coordinate everything and allow you to make bots your bitch. And then you have the bots themselves, which will be basically these bad boys. So using 600,000 of these, which don't look that powerful, you can do really a lot of damage. And basically, I mean, best way to fight against these botnets, I think, is giving people legal framework to attack the attackers. And some people say, no, you will just trigger go down the rabbit hole of you attack them, they find the defenses, and now you're back at square one. And eventually what's gonna end up happening is that you're gonna make the attackers just have better OPSEC, which I think is retarded. Because, listen me out, if somebody breaks into your house, you should use a weapon to defend yourself. You will stand your ground, and I think that private sector should have that opportunity as well, because at the end of the day, like, many companies have went obsolete because of cyber attacks. Like, just recently, attack on Jaguar, I think it was Jaguar, some car manufacturer, it changed the GDP of the country, like, by a few percentage points. Like, these things have real consequences, and people not being able to defend against those and rely only on law enforcement, I think, is a huge bottleneck. Because at the end of the day, law enforcement is not some unlimited pool of resources. Like, they have the government funding, but the problem is they have bureaucracy, manpower issues, competency issues, like any organization. And I think that one way to close the gap between the attacker capabilities and defending capabilities is just providing a legal framework for actually defending yourself. That's pretty much it from me. Like, follow for more videos. Hack the YouTube algorithm by liking this video. Subscribe if I didn't say that, or maybe I did, doesn't matter. And let's see you next time.